This video is more examples of triangle similarity proofs. On this proof, we're given that angle S is congruent to angle V. So in our first statement, we have angle S is congruent to angle V because it's given to us. We have no fractions and we have no side lengths. Therefore, in order to prove triangles are similar, we would need to use angle-angle similarity. That means we need to have another angle marked congruent. It says that our next step says angle STX is congruent to angle VTU. So STX at T is congruent to angle VTU. These two angles are congruent because of vertical angles. Vertical angles. Now that these two are congruent, we have nothing else that we could prove because we don't have any other information. We can prove these are similar because we now have two angles that are marked congruent. So we would say angle-angle similarity. They are similar because of angle-angle similarity. On this next one, we have that lines are parallel. Again, when we're dealing with lines are parallel, we look for either the Z, which is the alternate interior angles, or we look for the F, which is corresponding angles. Okay. So the first statement is that segment AE is parallel to segment BD. That's because it's given to us. Since this is a step proof, you have to be careful about what is already given to you in our proof. Statement 2 is blank, but we have a reason for statement 2 is the corresponding angles. But on the third step and reason, we don't have anything marked there, so we could make that anything we needed to. That would help us. Since there are no fractions and there are no side lengths, we have to use angle-angle in order to do this, and that's the last reason. So we know it's going to do angle-angle. We have to have two angles. Corresponding angles came from the F, and we do have the F there. So if I use my parallel lines and my F, I could have these two angles here are congruent because those are the corners. So if I say angle A is congruent to angle because A only has two lines going to it. I have to make sure I use three letters for this one. So we can say angle CBD because of corresponding angles. Now I can use the other corresponding angles as well because I have another F. So here's my other F. It's just an upside down F. But I can use these angles are congruent as well because of corresponding because I needed two angles marked congruent. So I can say that angle E is congruent to angle CDB because of corresponding angles. Now I have two angles marked congruent, so I can say that the triangles are similar because of angle-angle similarity. So I would say that triangle ACE is similar to triangle BCD because of angle-angle similarity. With a little similar part beside it. On this next one, we do already have two fractions and one angle marked congruent. So that leads to us thinking it's going to be side angle side similarity. We have to make sure that angle is in between the two sides that are marked. So our first statement is length GH over JK is equal to length HI over length KL. So I'm just going to kind of mark these. I'm just going to GH is right here over JK. And then HI over KL. Then we have statement 2 is angle H is congruent to angle K because it's given. This angle is actually in between these two marked sides, so that is good. That means that our two triangles are similar because of side, angle, side. Two fractions mean we should have side, angle, side similarity. 13, we have parallel. So again, we look for the F and the Z. So our first statement, segment MQ is parallel to segment OP because of it's given to us. Then it says that angle QMN is congruent to angle OPN. We got to figure out why. So angle QMN is congruent to angle OPN right here. So as you can see that these actually both touch a parallel line. So touching a parallel line. And it will also touch a transversal. So this is a Z. These would be congruent because of alternate interior angles. alternate interior angles. But then statement 3 and reason 3 also says alternate interior angles, so what's the other one? Because we have another z right here, this is another z, we have more angles that are congruent because of the other z. So we can say that angle, because there's only two lines going to this one letter, we can actually just say angle Q is congruent to angle O because of alternate interior angles, because that's the only letter at that angle. That's the only angle right there. So that means that you only have to use one letter. Now there are no side lengths, there are no fractions, so therefore we have two angles congruent. So we have angle-angle similarity. On this one, we're given that our triangles STU and triangle VWX are actually equilateral. That means that all the sides are the same. So if all the sides are the same, then that means all the angles are the same as well. So it says that angle S is congruent to angle V because that's the definition of equilateral triangle. Well, then angle T is also congruent to angle W because that's the definition of an equilateral triangle. Equilateral triangle. Well, then angle U is also congruent to angle X because of the definition of an equilateral triangle. You could also say that the sides are proportional because segment ST is congruent to segment TU, which is congruent to segment US, because that's the definition of equilateral. VW is congruent to WX, which is congruent to XV because of the equilateral triangle. Therefore, these sides have to be proportional to each other. But we didn't have to state all that because then that's just extra. But if you have an equilateral triangle, it's automatically equiangular because that's the definition of equilateral triangle. So actually we have all three angles, but you only needed two of them. But we can still say that triangle STU is similar to triangle VWX. You only had to put, so for reason 4, you could have just put angle-angle similarity. You did not have to put that extra third angle. That's just saying that those could have been the same thing. On 15, we're given that angle A is congruent to angle B. We're not given that they're parallel, so we can't say they're alternate interior angles or anything. So angle A is congruent to angle B because it's given to us. But then it says angle C is congruent to angle C. Now, why is that? Any time that you have a triangle sitting inside of another triangle where this angle is touching, like it's exactly the exact same angle for both triangles, that's the reflexive property as well. Just like when sides were touching sides, they touch the entire time. Same thing with these angles. These angles are actually holding on to each other. They're touching the entire time. So this is also the reflexive property. So we have no fractions, no side length. That means that our triangle should be similar because of angle-angle similarity.